All right, my dudes. LeetCode 169 majority element. It's a bunch of one-liner solutions so you can do this. Those solutions are not scalable. Okay, you're not going to find another problem where you can use that. So we're not doing it that way. It's going to be a scalable solution, hopefully useful for other problems. But given an array of nums of size n, return the majority element. The majority element is an element that appears more than n over 2 times. You may assume that the majority element always exists in the array. So one important thing to note here is that integer division here with the whole number divided by 2, it's gonna be floored. So if your n is 4 or n is 5, divided by 2, you get 2.5. So our number here that we're looking for is 2 for that example. So that's important to note as it gets pretty tricky. So just to get the scaffolding in here, what you can do whenever you have something where you want to know how many times something appears, or you have to know something like that, this is just a duplicate of the no duplicates problem or problems that are similar to that. So you can do is iterate through the list, right? And then what we're going to do is we're going to create a dictionary. So create dictionary of the number to the occurrences. Okay. And once you do that, what you can do is just iterate through dictionary, find number fitting the criteria mentioned in problem. So to just literally follow that through, the first thing we can do here is do a for num in nums. First we have to create the dictionary, so we're just going to say ndict is going to be to default dict of the integer with default initialized value, so dictionary. So then we're going to do if num in ndict. What we're going to do is we're going to say ndict sub num is equal to ndict sub num plus 1. So if the number is already in the dictionary, we're going to increment it, we're going to add 1 to it. And then if it's not in the dictionary, then what you're going to want to do here is set it to 1 because, you know, it's the first occurrence of it. So that's going to make the dictionary. I'm sure there's a one-liner way to do it in Python. I don't use this language, and it's the first time doing this problem. Iterate through dictionary. So what we're going to do is do key or number num to occurrences. So we're going to do some kind of tuple iteration nonsense here in n sub dict sub dot items. Boom. And then so we're iterating through the dictionary with this line. I'm going to place this after it. Find number fitting the criteria. So let me make sure these things line up. So if occurrences of the number, so the majority element appears more than n over 2 times. So if occurrences is greater than the length of nums, which is n here, over 2, then we're going to return num. This should be what we're looking for. Let's hit submit. It's the first time doing this problem, by the way. Occurrences is not defined. I run into this problem pretty often, actually. Let's try that again. Okay, so that's pretty good, right? So this, creating the dictionary. So this is going to be linear space because our size of dictionary is going to scale linearly with the input to the function. So this is going to be linear space. It takes linear time to create the dictionary. It takes, at worst case, linear time to find the item in the dictionary that fits the criteria. So this is linear time and linear space. Follow-up question: can we do this in linear time in constant space? I don't know about constant space, but there's another way we can do it actually. We can do it in place. So what we can do here is we can do the sliding window pattern. Sliding window pattern. So what we want to do, if we think about the problem, right? There's all these numbers. If we sort the numbers, right? So if we have a list that goes like this, 3, 2, 1, 5, 7, and then how many elements are in here? 5. So we need to add 3 elements that are all the same. So we'll just do 4, 4, 4. And then what we're going to do is we're going to sort this entire list first. And then what we'll get is 1, and I'll remove the 1 here. This is kind of, we'll swap these. This will be 3. We'll take these 4, these 3 4s. So we're going to sort the list, and it should look something like this. And then with the sliding window pattern, what we can do is we can visualize this list as a sliding window of contiguous elements, but we're going to make it dynamic. So what we're going to do is, you're going to try and follow this box with me. We're going to start at 1. We're going to be like, hey, is 1 equal to 2? If it is, we're going to grow the list. If it's not, then it's clearly not the number we're looking for. We're going to do the same thing here. These numbers are not the same, so it's clearly not the number that occurs more than n over 2 times. Boom, we go to 3, same thing happens, not the number we're looking for. As soon as we get to 4 though, we're like, okay. We check the number that's next to it, we're like, oh, okay, there's another number here. Let's look again. Oh, there's another number here. That's pretty dope. And then each time we expand the list, we're gonna check if it's the number that fits the criteria. And from here, we know that this is our answer, we can return it. 4 is gonna be the number that we're looking for. In the case that, let's just say that this is not the number that we're looking for, I'm just gonna add, we're going to take away a 4 here and add a bunch of 7s. If that's not the number we're looking for, then this, proceeds just like how it was before. We go to the next one, it's not it. But in the case that there's 2 numbers that look like it, the inner loop is going to be like, oh, we already looked through these, so we don't want to look through those numbers again. So we're just going to slide past and then start back at 1. So we look through each number in the list. So we only look through. We never, pass over elements twice. We just look through. If we processed an element, then we already processed it. And then when we get to the end, we'll be like, oh, 7 was the number that we were looking for. So the one way that we can do this, so the outer, so we're going to start here. So we're going to have a nested loop here, but it's still going to be linear time. Just the way that the while loop is going to work. So we're going to do while I is less than, so it's kind of like a for loop, while I is less than nums. And I forgot, we said that we were going to sort the list, so nums is equal to sorted nums. We're assuming for the sort here that's going to be done with an n log n time, so that's okay here. The problem is that this function is really going to be bounded by how long it takes us to find this element, so it's going to be linear time. So we made I is going to be equal to 0. And our current number, because we want to find the number that we're going to be looking for on each iteration, it's going to be equal to nums sub I. And just to make this a little bit more easy to follow, we're going to do outer and like this. And then inside, what we're going to do is say inner is equal to outer. And so in this inner loop, we're going to say while inner is less than length of nums. And so here we can kind of work our magic. So we're going to say if the current num, if current underscore num is equal to nums sub inner, that means we're starting on the window, and we're going to start on ourself as well because we want to count 1, 2, not 2 numbers being counted as 1 here. So we're going to start on ourself. If 2 numbers are the same, then we also have to keep a running total. Total for num, so total occurrences for this number is going to start at 0. If that is true, if current underscore num is equal to nums, so the 2 numbers are next to each other or itself are equal to each other, do total for num equals total for num plus 1. And then we're going to do a check here. If total for num, so this is the thing we were checking for earlier, right? The problem says that the majority element is element that appears more than n over 2 times. So if total for num, the number that we're on, which would be current underscore num, if total for num is greater than length of nums, doesn't matter, length of nums over 2. If that is true, what we can do here is literally just return current num as our solution. Boom. Okay. And then otherwise, so we want to keep iterating too. So if these numbers are the same, so we found two numbers that are close to each other that seem to be correct, and so we want to keep the while loop going because we want to see if we can find a third number, right? That'll be the number that we're looking for. So what we're going to do here is do inner equal to inner plus 1. So that'll get us 2 7s, and then, okay, we found another 7. Okay, 3 7s. That's good. But if we look at it for 4, if we do 4, okay, that's good. Another 4, okay, that's good. Uh-oh, we found a 5. That's not good. So if current number is equal to the number, then keep going. Otherwise, that's not good. The next number didn't match the running total of numbers that we're currently checking, which is 4. So what we're going to do here is set. We're going to break out of this loop. At the same time, we already iterated through to these two 4s, right? We don't want outer to start back at 4. So what we're going to do is we're going to set outer equal to inner minus 1. Outer equals inner. We're going to break here, and then just so we update the value in the inner loop. Oops, oh my god. Yeah, oh, that's good, yeah. Yeah, we're going to set outer equal to inner, and then we're going to do outer equals outer plus 1. So this should work. Let's see. Else, invalid syntax. I'm not sure what's invalid. Oh, oops. No, wait, this should be good. Else. Oh, oops. I think it should be like this. That's my bad. We're going to run. Output is none. Return current num. Two, return current num. Oh, yeah, wait, no. Inner plus 1. I think we might need this one right here. Oh, right, okay. So let's submit that. Okay, the reason why we need the inner minus 1 here is because if you look at this, so if we start with the first number, then we expand the list the second number, right? And then we don't find the third number that we're looking for. We're on the 5th index, right? But when we pop out, if we set outer equal to inner, then we start here. What we really want to start is, oh yeah, so we'll start here, right? We think we'll start here, but the problem is once you break out, we increment outer again just to keep this loop going. So we actually start here, which is a problem. So what you do is you start inner, we'll set outer equal to inner minus 1, so we'll start here, and this outer loop, this outer last statement will increment, and we'll start where we need to start so we don't overlap on any elements. That is majority element. First time I'm doing this problem, by the way.